day, my name is Richard and a warm welcome to Tutoring with Richard, where we cover the South African school syllabus and related topics. If you find these videos helpful, please consider supporting me on PayPal, Patreon or Buy Me a Coffee. Links in the description below. Today we're going to cover strength of materials in 6. The topic of this tutorial is combined direct and bending stress. Example number 2. Let's get straight into it. Okay. First things first is we need H. So H is on our table. If you look at your table, H is 355,6 millimeters. Right, so let's have a look at the question. It says an H section 356 by 368 by 129 kilograms per meter is shown in the figure. Is used as a short column and loaded as shown. Calculate the stress in the flange ML and NK. Now these are loaded very differently. This is 160, so 200 from 220 from the center, and 300 from the center is 120, and so on and so forth. So these are how they are loaded. This is how it's loaded. Okay, so H so far, we needed our table for. So Y equals H over 2. So Y equals H over 2. So 355,6 over 2 is 1778. Y is 177,8. Millimeters. Now, the next step is to calculate M by 160, which is equal to 160 times 10 to the 3 multiplied by the distance. So that's 220. So that's 0,22. And that gives me M of 160 equals. That will give me a total of 160 times 10 to the 3 multiplied by 0,22. 35,2 kilonewton meters. Okay. Next one is M, so 35,2 kilonewton meters. So M at 120 is 120 times 0,3. 120 times 10 to the 3 times 0,3. 120 times 10 to the 3 times 0,3. Exactly 36,000. 36 kilonewton meters. So, M at 120 equals 36 kilonewton. Alright, the next step. We need to find our resultant bending moment. This is a bending moment, so it says calculate the stress at ML and NK. So the resultant would be at M. So it is M120 minus M160, which equals 36 times 10 to the 3 minus 35,2 times 10 to the 3 equals 800 Newton meters. Okay, so this is 800 Newton meters. And you can easily work that out. 36 minus 35 is 1000. 1000 minus 200 is 800. So, NK 800 Newton meters. So, what we're going to calculate now is use ND and NB. So, what we have now, we have everything we need, and IX. So look on your table. That's 403 times 10 to the minus 4. Times 10 to the minus 6 actually. Okay. So M Y over I X. So I X is equal to 403 times 10 to the minus 6 and A and our area is 16,52 times 10 to the minus 3. So let's go for B. Equals M, which is 800, times Y, which is 177,8. Actually, it is 0,1778 all over IX, which is 403 times 10 to the minus 6. Okay, so our answer will be, we worked out M, so 800 times 0,1778 over 403 times 10 to the minus 6. We have our B is 352,953 kPa. Okay, so 352,953. kPa. Now we work out the other side, the D. As we did there. D is F over A. how we work out F, 160 plus 80, and I got this and I got that wrong. And there's 80 kilonewtons plus 120, all times 10 to the power 3. Those are all forces acting over the area, which is 16,52 times 10 to the minus 3. And that should give us a nice number. So, in the bracket, 116 plus 80 plus 120 plus 10 to the 3, all over 16,52 times 10 to the minus 3. And this equals 21,792 kilopascals. Right. So now what we need to do, that's not kPa, that's megapascals times 10 to the 6. That's megapascals. So now, what we need to do is go for the max. This is the max at NK, which equals max is 21,792 times 10 to the 6 plus 352,953 times 10 to the third, all equals 21,792 10 to the 6 plus 352,953 plus 10 to the 3. Okay, what we have now is 22,145 megapascals. That is the maximum at NK. Now what we need to do is calculate the minimum stress at ML, because that's what it is. It's the minimum stress at ML. So all we have to do since we've worked all this out, min at ML, right, so it is D minus B. D minus B, which is equal to 21,792 792 times 10 to the 6 minus 352, comma, 953 times 10 to the 3. And that comes out to 21, comma, 792 times 10 to the 6 minus 352, comma, 953 times 10 to the 3 equals. And our final answer is 21. This is the first answer that you need, and this is the second answer. 21,439 megapascal. That is our final answers, and that is exactly what they are looking for. They're looking for the maximum stress on one side and the minimum stress on the other side. So if you look at this, ML, they're looking for the minimum stress here. They're looking for the maximum stress over here at NK. The reason they're looking for the maximum stress here at NK is because there's more going on at NK. There's more going on at NK. Because here you have 80 kilonewtons here, and you've got 120 kilonewtons here, and so on and so forth. You've got more going on this side. So that whatever side has more going on, so whatever side here has more going on with it, is the side that will be your max, and the side that will be your minimum is the side that has less going on. Okay. If you found this tutorial helpful, please give it a like and subscribe. It really helps with the algorithm and to grow the channel. Positive feedback is most welcome. I enjoy reading your comments. Please use the comments section to let me know what topics you would like me to cover in upcoming videos. Be at peace, be kind to each other, and remember, passing well is achievable. Have a great day. Looking forward to seeing you in the next video.